to be calculating the enthalpy of reactions using bond energies. So this is our reaction, and the equation for enthalpy of reactions to using bond energies is the sum of the bonds broken minus the sum of the bonds formed. Oh, not broken. So another way of writing this could just be the sum of the reactants. And when I say the sum, I mean the sum of their bond energies. So the reactants minus the sum of the products. So basically reactants minus products bond energies. So now what we're going to do is draw out each molecule. This will help us determine the energies that we need to find. So CH4. CH4, I'm going to draw it down here. So you have C, H, 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 CH4. Now O2, I will draw. O2, it looks like this. So O with double bonded between each layer. Okay, now we're going to do, let's see, CO. Carbon would have triple bonded, actually double bonded to oxygen. We're just looking at the bonds. We're not looking at their valence electrons or anything. And then, where did it go? H2O would just be H like this. Okay. Now to calculate the bond energies, we're going to look at how many of each bond we have in each molecule and multiply it by the coefficient. So for CH4, we have 2, because that's the number of moles or the coefficient, times, what is the bond energy for a CH bond? We have 1 CH bond, 2 CH bonds, 3, and 4. So we're going to have 4 times the bond energy for each CH bond. And that's going to be right here. Okay, CH, 413. So we're going to have 413 here. Now we're going to take the bond energy of O2. So we're going to do plus, the coefficient of O2 is a 3. So we're going to do 3 times, and it's O2, so I already drew that. It's a double bonded between the oxygen. So the double bonds between the oxygen have a bond energy of 495. So we're going to multiply that by 495. Okay. Now we're going to subtract that from the CO bond energy. The coefficient is a 2, so we'll multiply that by 2. If we drew CO, we see that it's C double bonded to an oxygen, and that bond energy is 799. So we'll do 799. Now we're going to add that to H2O's bond energy, which has a coefficient of 4, so multiply it by 4, times HO. H2O has H single bonded to oxygen 2 times. So single bonded HO is 463, but there's 2 of them. So we'll have 2 times 463. Now I'm going to erase everything on the top so that we can continue our problem. Okay, so I'm going to continue the problem in blue up here. I'm going to go up here to blue. Okay, now 2 I'm going to multiply everything out. So here we had a 2 times 4 times 413, which is 3,304. 3,304 plus 3 times 495, which is 1,485. Subtracted from 2 times 799, which is 1,598, plus 4 times 2 times 463, times 4 times 2, so 3,704. So that should equal to, let's see, 3,304 plus 1,485 is 4,789 minus 1,598 plus 3,704, 5,302. 4, 7, 8, 9. And the answer to that is negative 513 kilojoules. And that is your final answer.